Hello everybody, welcome to the show. I have taped myself going over the notes here so that I didn't have to be directly teaching you. You can at times when you're watching this ask questions if you have any, but primarily it should be a tool you can use to learn independently. The good thing is, because it is taped, if I do a couple of examples and you understand, you can fast forward to the next type of problem. If you need to watch every single one, then watch every single one. But if you don't, watch a problem here and a problem there, that's fine as well. You can fast forward. Now everyone should have in front of you the Graphing Piecewise Functions note sheet. After you get done with this note sheet, taking notes on it, again, you don't have to finish it. You have to do as many as you need to grab a clear understanding of it. After that, you'll grab your homework, which is over on the top of my desk, and commence to starting the problems. There'll be a couple of us in the room today, myself and Mrs. Jones, so either one of us, if available, can help you once you start doing your classwork homework assignment. Okay, so we're talking about piecewise functions today. Oh, I was also going to say, the good thing about taping is that if you don't understand something or you miss something, you can always rewind, go back, and check out. All right, let me give you some general information. You're used to seeing graphs that are called continuous graphs. And a continuous graph, sorry for being ugly here, a continuous graph is something like a straight line or a line segment, or maybe a parabola, looks like that. But those kind of graphs are called continuous. They don't have any points where they are discontinuous. They have no points where they stop and start again. A piecewise function does have those kind of points. A piecewise function might be two lines. You might have a line coming down from this way, and then it stops with a hard stop, and then down here, soft opening, it restarts again. Now it's going a completely different direction. This is called a piecewise function. And this point right here, whatever that point is, that's called the point of discontinuity. It's where the graph changes places. You can't draw the entire graph without picking up your pencil, going to another spot and starting over again. And piecewise functions can look like anything. They can be two lines like you see here. Maybe they could be a parabola and a line. Maybe you got some parabola that comes down, stops right here, and then at that same spot up above picks up, and you got a line going the different direction. That would be another example of a piecewise function. So we're going to start learning how to identify piecewise functions, how to graph piecewise functions. So let's troll back here. All right, problem number one, A, B, and C. What we have here is a piecewise function. You're used to seeing things that look like y equals 2x plus 7, or y equals x squared minus 5. Well, those aren't piecewise, those are continuous, so it only takes one piece for each of them. Instead here, we've got a piecewise function, and this is telling us it's two pieces. Part of it is x plus 2, the other part of it is 2x plus 1. And this gives you the condition for when that graph is which one. When x's are smaller than 2, the graph looks like the line x plus 2. But when x's are greater than or equal to 2, the line looks like 2x plus 1. So these first three are pretty easy. It's just saying evaluate. Evaluate the function, so find the y value when x equals 0. Well, which condition are we in when x equals 0? X equals 0, that would be this top one. X is less than 2. So we plug the 0 in to the top equation. Obviously, 0 plus 2 equals 2. So when x is 0, y equals 2. All right, how about when we move down one here? What about when x equals 2? Where am I then? Well, you're right if you said greater than or equal to 2. We're in the equal portion. So we're using this piece of the function. We plug our 2 in right there. So we have y equals, oops, not right there, sorry. right there where the x is. We have 2 times 2 plus 1. Yes, doing a little bit of math, you realize that that is 5. So that's how you evaluate in a piecewise function. You find out which piece it goes into, then you simply plug in and solve. The last one here, when x equals 4. Obviously, when x equals 4, we are in the x is greater than or equal to 2. So we're going to plug the x equals 4 right there. So y equals 2 times 4 plus 1. Abracadabra, unless I'm really off today, that equals 9. Okay, let's move into our large examples here, our actual graphs. There are 1, 2, 3, 4, 5 examples. If you get the hang of it, if you think you've got it down pat after you see a couple of them, you can go ahead and grab the homework classwork sheet and start working. You can always come back and watch some more if you need to. In fact, if you start asking questions, I might ask you, did you watch all the examples? And you may be directed to go back and do so. But let's do this thing. Okay, number 2. We see the graph is in 2 pieces. When x is less than 1, we are at x plus 1. When x is greater than 1, we are at negative x plus 3. Negative x plus 3. So the first thing we need to look at is where is our point of discontinuity? Where do things change directions? Or do they change pieces? Where would you have to pick up your pencil? And we see that right in this area. When x is less than negative 1, when x is greater than or equal to negative 1. So that's our point of discontinuity along this x equals negative 1 line. So we look and say, okay, for this side, for x plus 1, when x is less than negative 1, if I plug in negative 1 for x, what will I get? Negative 1 plus 1 is 0. So we know for this part of the function, it starts, for lack of a better term, right here at negative 1, 0. Now, because it's simply less than, that's an open circle. So we have an open circle there, and we're going to go some direction from that spot. Now let's also go up and look at the other part of the function. This point of discontinuity at negative 1, so I plug the negative 1 in right here, and the opposite of negative 1 is 1. 1 plus 3 is 4. So this piece starts up here at 4. And because we are greater than or equal to, it's a solid dot. So solid here, I probably made this one a little bigger than I should have. Open circle here. I don't know why. I tend to do my right-hand sides first, so I'm going to do this one first. The one that's x is greater than or equal to negative 1. So I know I'm going to be up in this range, because I'm greater than or equal to negative 1. It says, when x is greater than or equal to negative 1, here is my equation. Well, I've got a point. If I have a point, all I need to use is the slope to get my next point, and so on. So what's the slope of this equation? Well, it's negative 1. So wouldn't I go down 1 and over 1 to find my next point? Down 1 over 1, there's another one. Down 1 over 1, there's another one. So there is my piece that goes on the right-hand side. And it goes out this way, and we know that it goes on, because it tells us x is greater than or equal to negative 1, it officially goes on forever and ever. So one side is done. Now taking a look at the other side. When x is less than negative 1, we have the equation x plus 1. So again, all we need to look at to figure out where I'm going is my slope. Now my slope is a positive 1. Remember, I'm going to have values over on this side of negative 1. So if I use my positive 1 and went up 1 and over 1, that would be going in the wrong direction. So I can do the opposite of that. Starting from my point, I can go left 1, down 1, and that will give me the same effect as going up that way. Left 1, down 1. Something like that. And now I'm going to finish by drawing my graph just as so. After we get that done, then we can look at our domain, range, and point of discontinuity. Well, the easy one here is the point of discontinuity. We've already discussed it. That point is when x equals -1. X equals -1 is our point of discontinuity along the x-axis. Domain and range, simply have to take a look and say, okay, what's happening with the x's, what's happening with the y's? First of all, domain. Well, I've got a less than -1 and a greater than or equal to -1. So isn't my domain just all real numbers? Sure, because x is everything less than 1, everything greater than or equal to -1. My domain is all real numbers. And you can see that. Every real number, every x value is used. How about the range? Is it the same? No, it's a little different. What's the lowest y value? Well, you see this going down forever, so my lowest y value is going to be -infinity. What's my highest y value? Does it go up forever? No, it doesn't. My highest y value is right here at 4, and it's a closed circle, so we're going to include 4. So my range is -infinity, 4. Okay, I hope that made some sense to you. Let's now look at problem number 3. Well, problem number 3, it starts out like the other problem did. Do you see we have the same point of discontinuity? Discontinuity over here is still x equals -1. So right along this -1 line is where our pencil will have to be picked up if we were drawing this graph in one piece. So let's look at two pieces. Again, I don't know why, but I always look at the right-hand piece first. And this time, here's the right-hand piece. For x's greater than -1, we have 2x minus 3. So let's first plug in this -1 right here. 2 times -1 is -2, minus 3 is -5. So we are down here at -5 right here. Is it an open circle or closed? Well, it's just greater than, so that's an open circle. That's my starting point, and I say, okay, I know I'm bigger than -1, so I'm out in this direction. What's my slope? My slope is 2. So, up 2 over 1, there's a point. Up 2 over 1, there's a point. Sure, let's go ahead and draw that. Make sure I don't mess that up. Good, so we're off in this direction. Alright, for the other side. Erase here. For the other side, when I plug in -1 here, -2 times -1 is 2. 2 plus 1 is 3. So I'm up here at 3, and I'm right here. Alright, and it is a closed circle because it's less than or equal to. So closed circle, there we go. Now, what's my slope? My slope is -2. So I'd want to go down 2 over 1, but I'm not in this area. I'm in this area over here, so I have to work it backwards. So up 2 over 1 this way, and there is my next point. So for this graph, I'm headed off, for this portion of the graph, I'm headed off in that direction. Oops, didn't quite hit it. It's the thought that counts. It all works just fine. Alright, we had a little recording blip there. Hopefully it all came through okay. The range, I don't know if you got this or not. I don't think you did, but the range is from -5. It starts right here, open circle, up to infinity. We're going up in both directions. Okay, increasing, decreasing. Just like with our rational functions, we're not dealing with increasing and decreasing at this time. So we're going to skip that, and we're going to move on down to problem number 4. Do you see anything different about problem number 4? Well, here's what it is. We're bounded. It doesn't say just x is less than -3. It says x's from -1 to 3 are x, and x's from 3 to 5 are x minus 1. So we're not going to have arrows that go on forever. We're going to have hard beginnings and hard endings for this discontinuous graph. All right, well, we have 2 points of discontinuity now. We have a point of discontinuity. I'm sorry, I apologize. We still have a single point of discontinuity. Problem number 5 has 2 points of discontinuity. we have a single point of discontinuity, and that spot is at positive 3. We look at positive 3, and we're going to plug it in for x. Well, positive 3 for x just gives us positive 3. So we are right here. Am I drawing an open circle or closed circle? Looks like an open circle to me. Now, from that point, we're going in the negative direction. I know I've broken my rule, I think, here. We're going down to negative 1. Well, where would negative 1 get us? Well, now I plug in the negative 1 here as well, and it would, of course, be negative 1, negative 1. So I'm right over here, and I have a closed circle. So this portion of my graph simply runs between those 2 points, like so. Now picking up my other piece. My other piece is when x is between 3 and 5. So remember how I start? I start at my point of discontinuity. My point of discontinuity was 3, plug in 3. 3 minus 1 is 2, so I'm right at 2 with a closed circle as such. And I look over and I'm at x minus 1, but all I have to do is jump over here and grab my upper bound, plug in my upper bound. 5 minus 1 is 4. So I'm at 5, 4. And that is an open circle up here at 5. So draw my next piece. It's from here to here. That's not the prettiest graph, but I think you get the idea there. Okay, let's fill in some things here on our left-hand side. Our point of discontinuity was at x equal positive 3. Our domain, well, we don't go on forever, so we're not going to have infinity involved. But where does our domain go from? What's the lowest x? The lowest x is right here at negative 1. So it's from negative 1. Oh, that's not a parenthesis, that's a bracket, because it actually touches negative 1 with that closed circle. And we go up to my highest x values here at 5, 5 being an open circle. So my domain is from negative 1 to 5. Let's look at the range. My lowest y value is down here at negative 1. Closed circle, negative 1, and it goes up to 4. It goes up to 4 with an open circle. So the range is from negative 1 to positive 4. Again, the difference in number 4 than in numbers 3 and 2 was that we were bounded. We were bounded here between negative 1 and 3. We were bounded here between 3 and 5. So it doesn't go on forever. There's no arrowheads. It stops here. It stops here. All right, moving on to number 5. Oh, look at number 5. Number 5 has 3, 1, 2, 3 pieces. It works just like 2, 3, and 4, except there are 2 points of discontinuity. Can you see where the 2 points of discontinuity are? Well, they're right here. The first one is negative 1. The second one is positive 2. So the points of discontinuity are x equals 1, negative 1, and x equals positive 2. So let's go see what we can do here. Let's draw our first piece. Our first piece, when x equals negative 1, so we're down here on this negative x equals negative 1 line, we plug in the negative 1. When we plug negative 1 into negative x, we get positive 1. So we're at negative 1, positive 1. Open circle or closed? Of course, it's an open circle. And that says it goes below negative 1. So we know we're over in this range. So we look at the equation, y equals negative x. What's our slope? Our slope is negative 1. Normally that would mean down 1 over 1, but I'm not in that area. I'm in this area. So I do the reverse, up 1 over 1. There's a point, up 1 over 1. There's a point. So let's go ahead and draw that piece of the graph here, heading off in that direction. Now, I'm going to look at the second piece. Now the second piece is a little strange. It says between -1 and 2, y always equals -2. Well, what kind of line is y equals -2? Well, that, of course, is a horizontal line. So we've got a horizontal line at -2 between the x values of -1 and 2. Well, that's easy enough. I go right down here at -2, and from -1, that's a closed circle, all the way down to 2, that's an open circle, I have a horizontal line. So from here to here is piece number 2. Now I get to my second point of discontinuity. My second point of discontinuity is 2, right where I stopped the middle portion. Now I'm going to deal with when x is greater than or equal to +2. All I do is I plug in my x value. 2 times 2 is 4. I'm up here at 2, 4 with a closed circle. What's my slope? My slope is +2. Up 2 over 1. Up 2 over 1. And here is my next piece, running this direction. There we go. Just as easy as the others, or just as complicated, you may say, but we're throwing in one more piece, and this piece was a constant. F of x equals -2. All right, let's do our domain and our range. Domain, what x values does this thing take? Well, this piece goes to -infinity as we go this way. Here, this piece goes to +infinity. So it looks to me like the domain is going to be all real numbers. Hopefully it looks like that to you as well. The range here, the range is a little tricky. Is it all the y values? No, but it's a lot of them. Well, I got a couple things going on. First of all, I've got this horizontal line. So isn't 2 part of my range? Just 2. So 2 is part of the range. Is there another part? Sure. Oh, that's not 2, that's -2. I'm sorry. So this is -2. We're going to go ahead and put that in brackets and say -2 is part of a range, but there's another part. So we're going to make a union. So the union of -2 and what? Well, oops, my phone's ringing. Okay, so let's talk about number 6. Number 6 is an interesting one because it has a parabola. Part line, part parabola. We see our -x² here. So let's first talk about our point of discontinuity. The point of discontinuity, everyone sees it, x equals 2. We're not going to do the increasing, we're not going to do the decreasing. You're welcome for that. All right, let's go over and take a look, and let's do the easy part first, what I'll call the easy part. They're both kind of easy, but let's talk about where x is greater than 2. So greater than 2, we know we're over here. Let's figure out where we're starting. We plug 2 right in here. 2 plus 3 is 5. So we're at 2, 5. There's where we begin. Closed circle, yes, I'm doing that right. So we are at a closed circle. And then I look at, okay, what's my slope? My slope is 1. Up 1 over 1, up 1 over 1. That piece was quite simple. Here we go in this direction, pointing right there. Okay, the second part. Second part is a little more interesting. It's a parabola. It's going to cause you to remember a couple things about your past math classes with parabolas. So when x is less than 2, so we're going to plug our 2 in right there. And remember, this negative is not included in the square. If it would have been, there would have been parentheses around the -x, and the whole thing would have been squared. But now we're squaring the x and then changing the sign out front. So 2 squared is 4. Negative out front, -4. So 2 and -4. Open circle or closed? Looks like an open circle to me. Then we have to stop and think for a minute. Okay, what does this look like down here? Well, hopefully you recognize this, y equals -x², as simply the parent function of a parabola flipped over. The parent function of the parabola, of course, has a vertex at 0, 0. So we have a vertex here of 0, 0. Let me change colors to keep in tune with the other. So there's my vertex at 0, 0. And what hopefully you also remember about a parent function is that from the vertex point to get to our first nice graphable point, all we have to do is go up 1 over 1, up 1 over 1 on both sides. But now we're flipped over the x-axis, so we go down 1 over 1, there's a point, down 1 over 1, there's a point, and now I can draw my parabola. On this direction, we come right down here, hits that point, and stops. Over here, we round this off, come on this, and this goes on forever. So there we go, a piecewise function with part line, part parabola. What's my domain? What x values am I working with? Well, looks to me like I'm working with all my x values, doesn't it? My domain, all these x values over here have values. They're really low, but they have values. Then all my x's over here, we're going up forever this way. So the domain is all real numbers. It's the range again that gets a little tricky here. Well, my range, this goes down to negative infinity. So it starts at negative infinity, and it comes up to 0. It stops right there. So my first piece from negative infinity to 0. But that's going to be union with a different piece. I've got no y values in here. My y's pick back up at 5. And then they go up forever and ever. So negative infinity 0, union 5 to positive infinity. Alright guys, you've heard what I have to say. Hopefully you've taken it all in. It's time for you to get to work.